Okay, this is the video, hopefully short, that describes the differences between this semester's 3 ME30 Fall 2015 Arduino kits. So the one you saw in the other video, the long, dragged down 56-minute video that you may have already suffered through, this is the kit board stack that you just saw in that video. Regardless of which of the three kits you're getting, you get the really hard indestructible box, you get a USB cable, you get the extra servo pieces that came with each of the servos. These are snap-on, screw-on flanges that connect to the shaft of the servo motor that you can glue, screw, rubber band, whatever onto to make whatever you want the servo to spin for you. So the extra parts are included in a little bag, and there's a little pink anti-static or static proof bag, I'm not sure which it is, that I bought a ton of last semester and never really found that great of a use for. I think actually if you do what I recommended in the last video and that you stash away your Pew board until the week or weeks that you need it for labs, then the Arduino and the experimenter board will actually fit fairly nicely in this bag. So it's in here if you need it. They're fairly useless to me otherwise. That's not totally true. So once again, this is the standard kit. It does not include the rotary encoder, which you'll see shortly, the terminal block for making connections out to any breadboard that you might be using with it. Let's do a little zoomulation here. Or it doesn't include the little ground loop, which is down here in the corner, and I'll show you these. I'll show you them now. So this is the standard board. I suspect most people will want this, and I made more of these than anything else. Note that if you decide you want these extra pieces later, they can always be soldered on. So once you learn to solder, I can either give you those parts or I can solder them on for you. But each one of these boards can have those parts put on later. So just because you get a standard kit now doesn't mean you can't be deluxeified in the future. So that's that. This is the deluxe board, and it has the rotary encoder on it. Now what this guy is that this is a nice clicky, don't know if you can hear that, it's basically a radio style or panel style rotary knob that clicks, I forget how many, 24, 30 times per revolution. And it is fundamentally, it is it mimics a kind of sensor that you use for sensing motor speed and direction, which you'll learn about in ME106. So it is a rotary encoder. This one happens to be mechanical. Ones that are used in motors, in industry are almost always optical. Sometimes, most of the time, don't know which, they're magnetic. But they basically, as you spin them, they emit a pulse train that are digital that you can use to tell how fast the thing's being spun and which direction it's being spun. So it's a fairly cool little thing. It's a nice little programming exercise. And the test program that you saw demonstrated in the last video exercises this. So not only can you test it, but you can see how to test it or how to use it. Over here is a 3-terminal block. It's got, it's kind of blocked right now, but since I'm expert at removing these, as you can maybe see there, yeah, you can see it. There are 3 connections in there which have screw down pivots, pistons, whatever you want to call them, on top. They grab wires, and what these are good for is each one of these 3 terminals is either 5 volts, 3.5 volts, or ground. And this is a nice way of running extra wires out to a breadboard when you need power and ground to be able to power those devices. The reason why you may want to use this instead of the holes that are in the power header over here, I keep on walking off the video, sorry, is that by sticking the wires in here, they're not totally loose, but you can yank them out. So by having these be screwed down, hard fixed terminals, These are 3 less wires that are going to become disconnected when you move your project around from place to place. You're already going to have enough trouble dealing with the loosey wires that are on your breadboards. This helps eliminate 3 of them. So that's handy for this reason. And there's also a tiny little ground loop on here. There you can see it against the black background for connecting an oscilloscope or logic analyzer probe. It's a ground connection. So it's one more handy little thing once you get in the lab and are using the test equipment to be able to help you debug your Arduino programs or just see what they're doing in terms of their waveforms on scopes. The other thing I forgot to mention is that all the boards, all kits, and you can see these ones are coming off, have rubber feet on them to help isolate the board from any conductive surface that you may put it on. One of the rules I should have mentioned in the other video is that don't use your board and power it up on any surface that's conductive or has any conductive crap laying around on it, like loose wires or coins or tools or whatever. Because there are live connections on the bottom, if you short any 2 of these together, you may find yourself buying another Arduino. So you probably don't want to do that. So always use it on an insulative surface. Oh, so that was one of the reasons why I included the pink bag, is that you can also use that to put your board on if for some reason you've lost these. These don't fit on here real well. If anybody happens to find any rubber feet that are deep enough to clear all these connections, meaning they have to be at least probably 3/16 of an inch, and that fit nicely all the places on the board that you might want to put them, let me know about them. I've pretty much tried every kind on Amazon, and you'll see a bunch of these attempts on the various kits that I'm selling now, and we'll see which ones people like and which ones they don't like. None of them are fantastic. And if you know of any, please point them out to me, and I will try them also. So that's the difference between the standard kit and the deluxe kit: the rotary encoder, the terminal block, and the ground loop. And let's put this back on. Let's not, we don't have time. Okay, so the other option is last semester's kit, which is fundamentally pretty much the same. The box is smaller because I didn't foresee that most people would want to carry their USB cables around in the box, and some people expressed that would be nice, so I got bigger boxes this semester. The other difference is, so there's no extra pieces on them, no terminal block, no rotary encoder. On some boards there are ground hooks actually, so that's a freebie, enjoy. The other difference is that the servos that I used last year are lighter duty servos. The gearing is nylon, and the lasers are these tiny little laser modules. The problem with the laser modules, they're not ideal. These wires are really flimsy, and the connections to the laser are equally flimsy. So if you catch this on something, some students were breaking the wires off, and so I'd have to either solder them, resolder them if they were fixable, or in some cases I just had to trash them and resolder a new laser to them, to the board, and then hot glue the laser back onto the servo. So these little blue servos are very popular. They're very lightweight. They tend to be used in, I don't want to say UAVs, but small self-propelled planes, remote control, and I think they're 9 grams, which is part of the reason why they're popular. So the gearing is nylon, the shaft is clearly metal, has to be pretty much. But if you force these things, or you try and swing too high of a load on them, you'll wear and or strip the gearing that's in them. So the servos aren't that expensive. I mean, if you buy them at retail, they're probably, I don't know, $6, $7, $8. If you, for some reason, you want another one and you need a replacement, I think I'll sell them to you for like $3.50 or $4. So the difference between this and the standard one from this year is that the servo that's in here is a metal geared servo. So the complete gear set is metal. I forget which one, but ideally they're going to wear a lot better. They're going to survive a little more abuse than the nylon ones. But like I said, the nylon ones are fairly popular. There's a reason why a bazillion of these things get sold every year. So the metal servos should be heavier duty. I would think that they'd be able to supply more torque and they would basically just last longer. I will say that I'm disappointed in that as I bought a bunch of these things and about 15% of them didn't fully work when I got them. So each one of these has been tested and it moves over its full range of motion. The typical failure scenario for the ones that didn't work, I use didn't work in quotes, well, they didn't work, was that they were binding up a little bit internally, and so maybe they would only move one direction, or they would move one direction if you maybe gave it a little help, which isn't what you want. So all those are in a bucket somewhere. And I will probably tell the vendor that sold them to me that they have a 15% failure rate on those things out of the box. So hopefully these things will turn out to be better. I hope that the lifespan of these things isn't actually shorter, or at least is no worse than the nylon ones, but we'll find out. So keep in touch with me and let me know at the end of the semester how both your metal and your nylon servos held up for you. As you'll notice, the lasers are also different. Like I said, besides the connection mechanism being a lot sturdier, I mean, this is a much better casing for the laser itself. There's also a wheel focus kind of thing on the front. I think it is actually used for focusing at different distances. So if you find yourself constantly using this at 10 or less feet, you may find one better setting gives you better, there's a word for this in laser speak, better, I don't know, basically focus than if you use it over longer distances. So you can play around with this if what you're getting is a line and you want something more like a dot. Give it a spin while it's on and see how that works out for you. I have definitely seen moving the collar make a difference. So the differences are between the deluxe and the standard are rotary encoder, terminal block, ground hook, and the difference between this year's and last year's kits are the wimpier laser, the supposedly wimpier servo mechanism, and that is pretty much it. So that's it. So the pricing for these is 60, 65, and 70. And if you buy them the first day of lecture that they're offered, which is October 7th, I think, you get a 5% discount. And for those people that can't make it on Wednesday, I'm going to extend the $5 discount to Thursday also from noon to 4 roughly. So I'll hang around. I plan on being at lecture next Wednesday, and I will hang around as long as I can, as long as all of us can in the lecture hall. I don't know if there's a class immediately afterwards. If there isn't, I'll hang around there and sell boards. If not, we'll all march up to the vending machine area on the second floor of engineering, and we'll do our thing there. And that's also where I'll be from noon to 4 on Thursday. Cash is good. PayPal is okay if you want to pay by PayPal. It is an extra $2.25 because there's a PayPal troll that monitors transactions and will not let you cross the bridge unless you give it an extra $2.25 at roughly the $65 transaction fee level. So I'm just going to say it's $2.25 regardless of what the whether your boards are $55 or $70. $2.25 is fine to add on. Cash is fine. Cash is good. If you have exact change, that's even better. I will have some change with me. If for some reason I come up short of change, I will either give you an IOU or I will just take your name down and I will show up the following lecture, or maybe your lab if you want to go ahead and send me an email and tell me where I can meet you, but I will get any excess funds back to you as soon as possible, and that will be pretty quick, as long as you make yourself available. I actually live near campus, so for me to show up isn't a huge sacrifice. So that's the deal. This is the world according to Arduino for ME30 this semester. If you have any questions, feel free to go ahead and send me an email. I know that I'm using edushields@gmail.com to host the YouTube videos. But on the back of all the boards that I make, I also have my email address that I prefer to get board kit email at, and that's eric@edushields.com, EDUSHIELDS, and the Eric is ERIC. So that's it. I hope you enjoy your kits, and if you have any questions, come prepared with them to class. You can also email me if you see this video beforehand. And if you have any questions, just go ahead and blast them to me. I'm happy to answer them. Otherwise, I will see all or most of you at lecture at noon on Wednesday, October 7th, I believe. Maybe 8th. Don't know. You tell me. Thanks. Talk to you later. Bye.